Good morning, everyone, and welcome. My name is Patricia Ramirez. I'm one of the account managers here at Softtree, and for my Spanish accent, you may guess right, I'm mostly taking care of our clients in Latin America and Spain, but helping in today's webinar, which is called Balancing the MassHaul. We are going to be looking at earthwork optimization for road transportation projects. Specifically, we will focus on details about the MassHaul diagram and its more sophisticated relative, the Opti Haul diagram. We are going to discuss accounting for material types, balancing the MassHaul, and other available tools to optimize earthworks and to automatically balance the MassHaul. We are going to be using a mining haul road project, but a lot of the concepts that we are going can be directly applied to other road project types. Let's discuss some background before we get into details. First, a reminder about the MassHaul. The MassHaul diagram gives you quick, qualitative information about cut and fill volumes and earthwork movements. It is a graphic representation of accumulated volume at any station, and the value is the accumulated cut volume minus the accumulated fill volume up to that point. The difference between the MassHaul between 2 points indicates volume of, in this case, you can see surplus or waste, which is a positive difference, or a deficit, negative difference, where you are required to borrow material. The MassHaul diagram is really useful, but it has a few shortcomings. The first is that it is not prescriptive in movement recommendations between stations. It does not provide a detailed schedule of earth movement between stations. And second, it does not handle the concept of material quality, which is important in the case of multiple materials and quality requirements. So our development team at Softtree has created a more sophisticated MassHaul diagram that is called the Opti Haul diagram, and it addresses these deficiencies. The Opti Haul diagram here at the top shows movement by category by material between stations, where direction is indicated by arrows and the height of the arrow corresponds to the amount of material that is moving. The Optihaul diagram can account for material quality requirements and for direction constraints. All of this information can then be exported into a spreadsheet. Very useful for understanding the constructability, cost, and construction scheduling implications of your project. So the Optihaul diagram itself, it's a building block for another concept we are covering in today's webinar, which is earthwork optimization. Together with alignment geometry and a costing model, you can create an optimized vertical profile that minimizes cut fill and material movement costs. It can also internally balance the MassHaul. It is almost like an easy button. And now I'm going to pass it over to Matt. He's going to be jumping into an existing mine haul road project. Our topo data has already been imported and built into a terrain model. And we've been already designed a preliminary horizontal and vertical alignment. If you are interested in those initial steps of this workflow, we will include a couple of links in our follow-up email. And with that, over to you, Matt.
All right, perfect. Thank you for the introduction, and hello, everybody. Yeah, so just as introduced, we're going to focus on earthworks quantities, material balance. With that, kind of leads quite well into costing, and that leads quite well into optimization. So just a couple things that I'll get out of the way on my end of this talk is one, I'm pretty bad at going over time, but I suspect I'll be quite a bit under time in this than the hour we have allocated. So hopefully everyone's good with that. And two, a lot of what I'm going to present today is going to be based on explanation rather than just the click through in the process. So I'm going to try and explain the concepts, and with that focus on the clicks, but as introduced, we're not going right from scratch from square one survey data to a finished product. We're going to just live in this Earthworks quantities, costing, and optimization world. And it's one of those things I'm going to cover a pretty broad explanation for a lot of concepts. But it's one of those things too that some of the stuff that I'll cover may not be applicable for your specific project. Yeah, just information, you can use it as you like. It's one of those things that material movement, you can make it complicated or you can keep it quite simple, and what's most appropriate will depend on your project. So with that, we'll take a look at my screen that I'm sharing here, and I'll just give a little bit of a project overview for what we have on the go before I get into kind of the theory of things. So we have, in my plan view here, a proposed new pit location with the active mine site. So we want to build a haul road to access that and start developing the pit, tying into an existing haul road and our proposed pit location. The proposed pit hasn't been built yet, so it's not incorporated in our topo surface, but I'm just showing it so we have a good idea of what's going on. The project itself, once again, as introduced, is a mine road. So I'm using a mine haul road template that I have built. And with that, it's going to automatically add a berm if I'm in, if I have a drop-off greater than 3 meters. And it's quite large. So my travel width is 12 meters either side of center line. And my berm height is, I think, 3 meters or something like that. Yeah, the alignment that's been clicked in, it's been designed conventionally. So I've chosen the location. I've assigned my curves by hand. And for this project, I'm using a max grade of 10% and a design speed of 35 kilometers an hour. So fairly tight K values on my curves, but there are curves there. So now let's start talking about what we have going on for our material movement. And for that, I'm going to focus mostly in the plan view because we have our MassHaul diagram showing up. So with this, as Patricia introduced, we have our MassHaul diagram, and the MassHaul diagram tracks your cumulative cut and fill volumes. So that is to say, at the start of our alignment here, so station 0, our cumulative surplus is 0. So no surplus or no deficit. But as we start into our road, so right there I can see I'm well below my topo surface. And we can look at that in whatever view we'd like. We can see that we are cutting more than we are filling there. So with that, the cumulative volume is increasing. So as we work along our alignment, we are generating more of a surplus until we get to somewhere right around there where it peaks. So if we look at where it peaks, actually I can split hairs here and find an actual location for it. We have about the same amount of cut as we do fill. So this is your conventional cross-section cut and fill geometry. So at this location, we are, and it won't be exact, just wherever the cross-section lands, but we're getting pretty close here to having the same amount of cut as we have subgrade fill at this location. So with that, as we go over this crest, there's a point where that is a flat line in our MassHaul. So that flat line would be balanced cut and some fills. Then we transition into a location where we can see it here, the MassHaul dips away and we're losing that surplus. So we are filling more than we are cutting. Now with that, if we look at where that cursor is, we're right around here. So we're filling more than we're cutting, but the MassHaul diagram itself is still above the zero line. So this line is going down. So we know that we're creating, or we're filling more than cutting, but we haven't crossed this 0 point yet. So we still know that we have a net surplus along the road at that location. Then when we get to this point here, which is a little further, that's where we're balancing the cut we generate up to here with the fill that we generate from here to here. So if we expand that and look further ahead, so we're continuing our fill for a little ways. So we're filling through there, then we're generating more cut here, but we're not balanced yet. And we don't balance until all the way out here. So that's the gist of it. Now another kind of important concept is this is just showing you your surplus and deficit volumes. So that's not to say that this is indicating your total volumes at all. So in a theoretical world, we could have a road that was on a nice planar slope, and we could put that alignment in a location where at any cross section our cuts balance with our fill, and we could have a MassHaul diagram that, and again, theoretically, it never happens that way, but we could theoretically have a MassHaul diagram that follows the zero line with no spikes or dips in it whatsoever. So if we are interested in knowing our total cuts and fills, well, we won't really lean on the MassHaul diagram for that. We'll go over to a data table, and we'll set it up to show the information that we'd like. So I'm going to say I want to see my road station, and I want to see my cuts and fills. So that's my subgrade cut and fill. I'll include my surfacing volume here, and just to set us up to look at this down the road, I'll include my stripping volume. So that's that. I'm going to set my report points to show me what I want to see at whatever intervals I'd like to see it. So I'll report this in 100-meter intervals. And that's just recalculating here, so we'll hang on a second. So we've got that, and I'm going to turn on my design totals so I can see I am cutting almost 42,000 cubic meters, and I'm filling, 400,000, and I'm filling 363,000 cubic meters. So like I said, it's a big wide road, so lots of volume in this. If we look at our MassHaul diagram, and if we come out here, that tracks, because when we're ending with a surplus, and if we took that volume minus that volume, we get to see our surplus volume matches up. So that's kind of the gist of the volumes, but the MassHaul diagram is typically used for more than just tracking your surplus and volumes. It's often used to indicate material movement direction. So I'm going to right click here. I'm going to click MassHaul options. And I can see my advanced MassHaul settings down here. I'm going to turn on freehaul and overhaul. And for that, I'm setting my freehaul distance to be 30 meters. And I'm setting my overhaul distance to be between 30 and 250 meters. So what these categories represent are different ways of handling your material movement. So in this case, my freehaul distance of 30 meters is pretty representative of an excavator kind of doing that local movement on the at the heading. But if you had to move material, say 100 meters, you're probably not going to move that bucket by bucket with an excavator. So here we've got another category where we're going to treat that kind of long push between that 30 meter distance and 250 meter distance. And then anywhere beyond that 250 meter distance would be our end haul, where we are planning on putting it in a truck and hauling it to the spot we need it. So when we turn that on, and just to see, we've got some symbology associated with this. So green is my free haul and yellow is my overhaul. And if we zoom in here, we can see that this little blip at the top, so say from about there to there, that's what we could reasonably move just with the excavator. But then all these yellow movements are the long pushes. And then the material volume that lands outside of the green and yellow is that, well, it's too far to push with the 250 in this case represents my dozer push. Too far to push with the dozer, so we're going to load it in a truck and move it that way. Now, with this, we can see that there's some arrows being indicated here as well. So the general rule of thumb with glancing at a MassHaul diagram, and this kind of leads into some of the imperfections of a MassHaul diagram, is this is indicating that that material gets moved ahead. So we're creating a surplus, then we're creating a deficit. We're above the zero line, so it makes sense to take that and put that there. Whereas once we go below the zero line, typical rule of thumb is then you're moving that material backwards. So we've created this deficit. We don't have material to address that deficit at the start of our road, so we're going to get past there and pull that material back. So that's the direction constraint. And it's not perfect, and we'll get into that, but before we get into that, let's kind of look at another concept and introduce that other concept before we really get into the nitty-gritty of material movement. So on this project that I have, going from here to there, I have my subsurface horizons assigned. So when we can see that in my cross-section here, I've got a couple different materials shown. And let's go out to the end here. We'll see it's shallower at that location for those superficial materials. And right now I've got if I hatch that, I can see that's being tracked as my subgrade. So that's my subgrade cut, subgrade fill, showing up as the red. Now, before I get into the actual kind of stuff below my organic layer, oftentimes when building a road, you'll want to remove your organic soils. So you don't want that included as your fill, and you don't want to tabulate that as cut and fill for your subgrade because it's not ideal. It'll rot and cause other issues. So we can come in here and we can go assign by range. I'll set a site prep and I'll say, well, I want to remove 0.3 of a meter underneath my road footprint. So let's put that in here. My road footprint, in this case, I'm defining it to be based off of my slope stakes. So from top of cut to toe of fill, I want to remove that 0.3 meters. I'll hit OK. And we can see here we've got this surplus of material. And since we're not going to include that organic soil that we're removing in our subgrade, we'll notice that this MassHaul drops down. So we'll have less of a surplus than what we expect on. So that's, if you're stripping, it's worth considering that when you're planning and designing your road. And we should see our change. So volume's changed, it makes sense. We are, and I'll just go somewhere with this shaded area isn't being tracked as our subgrade. So that is being tracked as our stripped volume. And if we jump back into, let's look at that data table that we have our stripping volume being tabulated here now. So we've got 41,000 cubes of stripped organics. Another kind of geotechnical consideration that we can add in there is those horizons. So I've got in my assign by range, we assigned our stripping and site prep. We can say what materials along the length of our road. So in this case, I've told it that from station 0, so dot to 1604.4, I have hard pan. I've got 1.5 meters of hard pan over fractured rock. And then from 1604.4 onward, I've told it that I've got just 0.5 meter of hard pan over solid rock. So if I go in here, I can click this little button and say, well, I want to make that a meter. I could click OK and add edit, and that would change the assignment. So I haven't changed anything here. I'm just going to hit cancel. So those values here come from my ground type table. So I've got my hard pan defined here. I've told it that I've got different cuts and fills depending on the material that I'm working with. And I've got different expansion factors and fill factors in there as well, depending on the material I'm working with. So that's great. And right now I'm not worried about using different material along the length of my road. But I may be interested in that. So let's just come in here, and I've got this crossing here. And there could be a variety of reasons that you'd want to do this, but maybe my hard pan is a pretty poor material. I don't want to build this large fill with that poor material. I want a nice competent material. Maybe I have scour issues and whatnot. I don't want to use my fractured rock. I just want to use that solid rock for my fill material here. So we'll click assign by range. We'll go into our fill types. And right now I've told it that we can use our existing layer 1 and replace it with whatever is available. But I'm going to say from station 235 to station 585, I want to use solid rock. And if I leave this replaceable on, it will replace it with any material that is a Q3 material or better. Now, if I want that to be just solid rock, I'm going to turn that off. So now instead of being a Q3 material or better, it has to be that solid rock, the material type that goes in there. I'm going to hit OK. I'm going to hit OK. I'll let that think here for a second. So there we have it. Now with that, I've told it that that material that is being placed in there, so my ground types, solid rock has a steeper fill, so my volumes change a little bit in that location. So it wasn't just using the material that was on site. Now it's hauling that solid rock in there. But my solid rock material type is only near the end of my road. So if I just look at the MassHaul diagram here, it's not actually showing me where that material is coming from. So if we need that kind of more detailed look at our material movement to have a good idea of what's going on in our project, there's a better solution. So I'm going to come in here, profile options, I'll click select, and I want to show my Optihaul graph. And just so we don't have things too crowded there, I'm going to just remove this for now. So the MassHaul diagram showed one material, or material at a given location was either being moved forward or back. To build this with the material that we have and to account for the parameters that I've told it we need to account for, we can see here that we're actually moving material all the way from this end of the project to address that fill, but we're moving material forward in between here and there. So the MassHaul diagram doesn't account for this quality consideration. Now when I assign that new material, I mentioned this quality-based parameter. So if I come in here, oops, my ground types, we've got these geotechnical parameters assigned in our ground type table on this tab, but if we go over to costs, we can say, well, there's different quality parameters associated with this. So my solid rock, basically I'm ranking or categorizing my material in a poor, not great, good, and then best. So Q4 being best and Q1 being worse. So if I had assigned that material by range and made it replaceable, that would, and I hit cancel there just so we don't have to watch the computer think for a few seconds, that would allow me to use the fractured rock that I'm generating at this portion of my project rather than hauling it away from the end. So it gives you more control and the ability to see what's going on. Now I'm going to just show both of these here for a second. So we've got both those graphs. This is not really related to the theory. This is related to the functionality. If you want to get a detailed breakdown of what's going on for these, we can export that. Aside from just creating data tables in the software, we can open up Excel. And if I want the MassHaul information, I can hit copy all to clipboard. I can come in here, I'll click paste. So we've got our cut volume, centroid, cut centroid, fill centroid, and then a breakdown of that. Now this, where it lumps all that material together, you don't get to see that we're hauling material in different directions. So if we hit copy Optihaul to clipboard instead, I'll include it all here, we can see we get a much more detailed breakdown of our project and our material movement. So if I come down to kind of the movement summary portion, I can see I'm getting a movement summary for my hardpan material, a movement summary for my fractured rock material, and a movement summary for my solid rock material. And if we want to look at our cuts and fills by material type, we can create a data table for that as well here. Design totals. So let's add in our volumes Optihaul. So I want to see my hardpan cut, hardpan fill, hardpan cut, solid rock fill, cut, and fractured rock fill and cut. And there we are. So we can see that material, those material quantities broken down by material type rather than lumped together. Now with this, and this is kind of a devil's in the details thing, we can see these volumes. Now I'm going to turn off my Optihaul graph here for a second. Now if I come into my ground types, and I mentioned in passing my expansion factors, so that is telling the software that my 1 cubic meter of bank material, if I excavate that and try to put that material back in the same hole, I can only fit 80% of it back in the same hole. So it's going to expand. It's going to expand about 25%. So if I change that expansion factor here, since I've got multiple materials along the length of my road, the MassHaul diagram isn't tracking, okay, where is this surplus that we're ending with? Is that a surplus of solid rock? Is it a surplus of hardpan? They're going to have different expansion compaction factors for each. So it's not going to adequately account for the the change in that expansion compaction factor. Whereas if I show this as my Optihaul volumes, so I can pull from create the MassHaul diagram for my Optihaul. Use Optihaul volumes, and that gives me a accurate representation of my expansion compaction factors rather than just the generic MassHaul quantities. Yeah, so with this, I'll just, for the sake of showing it here, we've got 25,000 cubic meters of surplus. We can add a spoil site in here, so that is important for figuring out our material movement. So right now, we're just ending this with a surplus. We're not saying where that surplus has to go. So I can go into assign by range, and I can add a pit. I can say, well, let's add a pit. Let's make that pit at, let's go station 1500. So station 1500. We can tell it the type. So right now it's a waste site. So we can spoil that surplus material that we have. And if I were to not use some of this Optihaul technology, I could turn off variable volumes from our pit, and I could tell it explicitly how much material I want to put there. Since we have that, we have the technology, I'm going to tell it, well, let's let the software solve for how much material and what material to put there. I'm going to set a capacity, so I could set a capacity to be a certain amount. I'm going to say we can put however much we'd like there, and we'll hit OK. Recost. There we are. So we've got this big drop in our MassHaul. It's balancing at the end, so that's my spoil site. And if we open the Optihaul, so I'll stop jumping around here for a second. My Optihaul, I'll hit OK. We can see that that waste site is indicated by this little icon here. So I've got a waste site at that location, and it'll give me a breakdown of the different movements going to that spot. So that's kind of the gist of quantities, material movement. The next thing to kind of talk about here is, well, we're getting this detailed breakdown of where everything's going. We know how much we're handling. Part of figuring out where everything's going is to account for the cheapest solution. So we have costs. So I'm going to pop this open. So I've got my ground types here. We've talked about ground types for geotechnical parameters. If I go to the cost tab, so I talked about quality factor, but we also have unit costs assigned in here. So I've told the software that my hard pan material is going to cost $4 a cubic meter to excavate, and it's going to cost $2 a cubic meter to take that already excavated material and shape it into a road. Whereas my solid rock, if I'm drilling and blasting that, that's going to cost a whole lot more money. So I'm telling it it's going to be $25 a cubic meter to excavate. And there might be some sorting of the material. It's going to take a little longer to actually shape that into a road. So I've got that in an embankment cost of $3 a cubic meter. So we can have different costs for handling the material depending on your material type. I should also mention here, you can add whatever you'd like for your materials and save that for future projects if there's something missing from the default list. So for example, I've added a 1-inch minus well-graded base course, and I've added silt. So we can just hit new and add in whatever materials we'd like. So that's our handling costs and the ground types. We've also got our movement costs. Now the movement costs are shared amongst the materials. And just like the MassHaul diagram, we have different categories of our material movement in here. So we're telling the free haul, less than 30 meters, is going to cost $24 a cubic meter kilometer, 18 cents to load, whereas overhaul is going to cost 10 bucks cubic meter kilometer, 60 cents to load, and end haul is going to be 2 bucks cubic meter kilometer and $2.6 to load per cubic meter. And if we play with these numbers, I'll change that to 0.3. We change the split for where that's those categories begin and end. I'll also just mention here, you don't always get either the ground to work with certain types of equipment, or maybe that your builder doesn't have certain types of equipment. So if you need a two-haul system, we can go into free haul control to account for that. So with that, and I haven't really spoken of it so far, but as we've been doing this, I've been recosting, and that's spitting out a cost here for a total cost of $8.8 million. And we can see a breakdown for cuts and fills. So now that we've taken this process and we've made it really analytical and able to account for the complexity of some real world problems, we might as well lean on the power of optimization. And just as a sidebar, this Opti Haul calculation is an actual optimization problem too. Figuring out the cheapest direction to move your material, but we can expand on that and let's figure out the cheapest location to put our road. So rather than going through and balancing this by hand, actually I don't know if I showed that. I think I got caught up in the details here. I'm just going to remove my pit for now. So if I were to balance this project by hand with the MassHaul diagram, just wait for that to calculate, I would go through and I'd adjust my alignment. So in a perfect world, we're keeping our MassHaul as close to the zero line as possible while adhering to all of our design constraints. So at this location, I see that I'm creating a big surplus. Well, I would look for an opportunity to reduce that surplus. So I'd come in here, I'd add a IP, I'd lift my grade. And we'll see here, once that's done thinking, our MassHaul diagram changes, and it didn't change that much. I'm still generating more cut than fill. And oops, I'll turn that off here for a second. So it does take longer to solve. So now I've increased my fill, and there we go. I'm ending with a surplus or a deficit, in which case I'd want a borrow site to address that deficit rather than a spoil site. So we can move our alignment up and down, or we can move our alignment horizontally in and out to help find the cheapest solution for our road. Now, if we're one, that takes a while. Two, you'll never get the cheapest solution doing it by hand. And then three, if you want to account for actual quality parameters and direction constraints, it's really hard to do a good job of that by hand. So that's where we'll lean on the optimization side of the software. I'm just going to add in a duplicate here. So this is our vertical optimization interface. So I'm going to tell it sample in 20-meter intervals along the length of my road. I've got a preliminary alignment in this case that I've been using to talk about. So I'm going to allow it to move the generated alignment up or down a maximum of 10 meters either side of that preliminary line. We could use it from the ground line though if we had if we didn't have a preliminary vertical alignment. Here I'm defining my design constraints. So max adverse grade of 10%, max favorable grade of 10%, my minimum sags and crests values. And in this case, I'm going to just leave it fairly unconstrained. I'm going to allow it to have curves butted up against each other. If I wanted to have tangents between those vertical curves, I'd go with variable curves and tangents. So this is usually pretty appropriate for low volume roads. This is more low volume, low speed roads, and variable curves and tangents are better suited for faster roads, higher volumes, etc. I'm adding in a couple control points. So one, my road ties into another road. I don't want it to start in a cut or a fill. And I want the grade to match up with the existing grade. Two, I've got a control point out here at this crossing where I don't want to be any higher or lower than I've got it assigned. Pits, I don't have my pits assigned. I'm going to see if it'll balance internally without accounting for those. Our unit costs we've already accounted for. And then we've got our constraints. So I'm going to leave this fairly unconstrained, but we can add in other parameters as well. So it could be that kind of goes hand in hand with that material movement aspect. It could be that maybe we couldn't build this crossing by pulling material backwards, so we had to move material forward from station X to station Y. So you can put that in here. If you assign that here, the Opti Haul is going to account for it, and it's also going to account for it when we do our optimization of the alignment. We can allow side casting of material. If there's something that's not driven just by balancing cuts and fills, like we need a minimum fill height over a certain location, we can assign that. Same with full bench parameters or minimum cut parameters. So we're going to hit OK. I'm going to right-click here, click vertical optimization, and let this run through and figure out the cheapest alignment, taking into account all those material quality parameters that I have, any material movement direction constraints I've added in there, and then the design parameters, max grade, K values, etc., etc. So that's going to take a moment, and then we'll see our results. And let's see here. With that, I think I can probably answer a few questions that
Awesome idea, Matt. Just a reminder to everyone, if you have questions, please expand the webinar panel and you will find the question sections there.
all right.
So we have one here, Matt. Can you include your pavement materials in your costing and Optihaul?
Yeah, absolutely. So that is one that I can show how to do it here momentarily once this is done thinking.
Maybe we'll go back to that one.
Yeah.
Okay.
Yeah.
This is a comment too. Great webinar. Thank you. My question is, how did you import your surface data?
All right. So that is what's best for your project will depend. So surface data in this case, I'm assuming it's or subsurface data is kind of my ground types that I have assigned along the length of my road. So in this case, and this is also a fictional project that we're using for presentation purposes, but in this case, I've either relied entirely on kind of photo interpolation and interpolating the ground types based off the topo data, and I said, well, this is probably shallow soil and solid rock there, maybe based off of bedrock mapping or something like that. And I've tabularly assigned the ranges where my material changes and the depth changes for that material. So I've done that in the assign by range. And with that, it's up to the user to assign station X to station Y. In doing that, the material depths are an offset of your topo surface. So it's kind of a uniform blanket depth rather than having these independent surfaces that don't necessarily follow your topo surface. If you have that independent subsurface data that you want to use, you absolutely can. It's just a matter of you have to add it in. Well, first you have to generate a tin from it as a train file. Save that train file, and I'm very close to optimal here, so I'm going to. I'll let it run while I'm talking. So we can take that train file that shows our subsurface data, then we can add it to our design as its own layer, and we can pull that ground type topography from that surface, so it doesn't have to follow the ground.
Awesome.
So I'm going to hit cancel here, and so I'm within 0.3% of the optimal solution. Easily let it run, but just for the sake of being able to answer those questions with being able to point at the software, I'll hit cancel, and we'll see that within 0.3% of optimal, we're shaving off, I think it said $1 million there. And we'll get a alignment that is, well, humpy bumpy because I have a low design speed with small K values. So that makes sense, but it's going to track the topography closer than this by hand design. So it's going to minimize my cuts, minimize my fill, and it's going to find the best way to balance that material and where to haul that material from. Just a quick note there, the optimization is done. It's just actually generating all the stuff we want to generate to see what's going on. So there we can see we're balanced, very close, and we've gone from 8 point something down to $7.9 million. And if we want to look at a comparison between those two surfaces or alignments, we can see, well, that makes sense. Our original alignment was that green line, whereas now we're tracking up closer to the top of the surface. All right, now just coming back to that subsurface parameter question, we can go into our options. So corridor, options, train surfaces. We can add a subsurface train file. And then when we are adding our material types in assign by range, rather than assigning this as a fixed depth, we can use the surface. Now I don't have a surface to actually pull from there, so it won't look like much. So that's the gist of it. So I guess I can answer that first question. What was the first question again before I forget?
Okay. The first question was, can you handle your pavement materials in your costing and Optihaul?
Yep. So the right now this cost is just accounting for my subgrade construction costs. It defaults to that, but you can absolutely account for your other materials. So in this, so I can hatch and see what my subgrade's being counted as. And then I can come up here and see, well, that gravel running surface on this mine road is surface volume 1. So we can either assign a material to that here. So we can go surface volume 1 and assign that, or we can do it from the ground types, or sorry, not ground types, fill types. And we can click other materials and we can define that in here. So if I want my surface volume 1 to be made up of my well-graded 1-inch minus, I can click OK. So that's coming from that material. It's not replaceable. We can hit OK. We're going to recost, and we'll see that number gets quite a bit bigger because we're accounting for a whole lot of expensive material to actually build that gravel top. So will that think? So we can go on to the next question.
Okay, I have another one here. Very interesting. Can you set max distance and max grade?
No. So, well, the grades when we sign the optimization are assigned by range. So, and just that's done calculating here. So by adding in that well-graded 1-inch minus, we've jumped up $1 million in our costs. So when I come in here and hit standards, my grades are assigned that way, but we can assign different design parameters for different sections of our road. So I don't have a great example here, but a common example would be, say, going around a switchback. So steep roads, usually it's nice to have those switchbacks less steep than your max grade elsewhere on the road. So we can say, well, from station 500 to station 600, and I'm doing this just arbitrarily, set that to -5 and +5. So there we've got different grade parameters for a specific section of road. And you can do the same for your K values as well. Yeah, so I won't re-optimize that because I don't even know what topography looks like at 5 to 600. Yeah, it needs to be steep to work. So. All right, and any other
Okay.
questions?
We do have a lot of people
Okay.
and a lot of questions today. Okay, so the next question is, so we can take this into the next level with multiple existing layers. And there's an example here with 3 materials, OB.3 loon, 1 steel tilt, and
Okay.
1 HP 2SR. I guess that makes sense
Yeah.
to you.
Yeah. So
Sorry, it says to strip and rank all the materials in a complex glacial cross-section.
so with that, you personal preference will prevail, but oftentimes for the loon, I assume that is your goop. Oftentimes, and it'll depend person to person and whatnot. You can account for your overburden without assigning it as a specific sub-horizon. So it's just going to get pulled out of there, tracked as stripping, so you don't necessarily have to split that out as its own layer in your sub-horizons. For your sub-horizons, you can account for your complex layers. It's just a matter of assigning it by range for what you have. So you have up to 3 ground type layers and assign different depths for those and different ranges for that material. And just for the sake of kind of looking at something a little more interesting here, I'm going to, so we're at station 600. Let's go from 585 to 685. Oops, I'm in the wrong spot. So 585 to 685. I'll have my stripping that's taking care of that organic soils layer. I've got my hard pan, and I'll make that a little different than what's around it. Let's call that 5 meters deep. I'll say that we've got solid rock beneath our fractured rock. So I'll say that we have 1.5 meters of fractured rock. So this is measured from the topo surface. So 5 plus 1.5 meters is 6.5. And then the rest of our material, we have that solid rock. I'm just using the material types I have along here, but you could absolutely add in other materials or change terminology to suit. So if you didn't want hard pan, you wanted to call that till, well, you could change the name, or you can just click new and call it till, and you can create that specific material to pull from. So there we are. I'll hit OK. Oops. What? I'll hit OK. I'll click Add Edit. So that's important. Right now, if I hit OK, it's not updated in this list. We click Add Edit to update the list. And once again, it's going through. It's not redoing my alignment, but it is solving for that complex Optihaul, where each material is going. It's doing that all for us in the background. And yeah, then we'll be able to see that different cross-section here. And once again, I used the blanket offset, but we have, if we had a surface that we could pull in, we could have that. So these lines don't follow the surface. They could be independent of the topography. So hopefully that answers the question.
Excellent. Thank you, Matt. And we have another maybe comment here, maybe needs clarification. So less cut being tabulated, but also more fill is being used because the subgrade surface is lower.
Yep. So I think I know what he was getting at there.
Okay.
Yeah, he was referring to when we were adding the stripping in. So I'll, it's a little less complex, easier to see if we just look at this one here to get the gist of it. Actually, let's look at the unoptimized one. Move to some things. So with that, the comment is originally we didn't have the stripping assigned. So if we had our road design and it was balanced, so our cuts and fills equal out without accounting for stripping, and then we actually strip it, we are basically the material that we can use is lower than what we were planning on, because the first, in this case, 30 centimeters was garbage. So our road is basically 30 centimeters too high. So being 30 centimeters too high, well, we're cutting less material just because it's not being tracked as subgrade cut, but we have to account for that material that was no longer there now too. So that's where that balance gets out of whack. Boom, 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 boom. Let's see here. Let's turn this off just so it site prep.
And Matt, a compliment to that last question is this is for when you add stripping here.
Yep. So okay. It's getting there, just kind of having to undo some things to get to the gist of what I wanted to show. Yeah, trying to get it back to the way it was when we first talked about it. So right now, this design, I've removed my stripping, and our material, so our subgrade cut goes right up to the surface. If we're in fill, that fill stops at the surface. So let's add that cut back in, or the stripping back in, so 30 centimeters. So we'll see the MassHaul changes. So now that we're stripping, that fill, that stripped layer, is removed before we're building our subgrade, so the fill has to go down to the stripped topo surface. And then when we're in cut, that cut isn't including the stripped material because we don't want to use that as fill down the road as well. So that's hopefully addresses the comment. And look at us, we're think right on time, or a little over.
Yeah, I think we will end with this question. Thank you, everyone, and we hope to see you here next time.
All right. Thanks, everyone.